Get the last one. Our objective for today, I can factor polynomials. Repeat together. 1, 2, 3. I can factor polynomials. So we're back to polynomials, your favorite. Yay! So give me a second. So we're back to polynomials, and today we're going to be factoring polynomials. So for the prior model, you already started filling it out since you already know the definition for polynomials, right? Okay. So polynomials. Write some examples of polynomials in your prior model. I want to see if you remember your definition, since I repeated it like 1,000 times that day. Something like that. Oh, that's true. Here it goes. So, polynomials are monomials or sum and difference of monomials. And let's see. Is 2 a monomial? Yes. Is x squared a monomial? Yes. Is negative 3x to the 4th plus 2 a monomial? No. It's a binomial. But how many monomials it doesn't make this binomial? 2 of them. That's why it's 2 terms. This one is a trinomial. How many monomials does it have? 3. 1, 2, 3. All right. So look at the non-examples. 2 equals 2x. X squared plus 3x plus 2 equals 0. And negative 3 plus x equals 10. Why are these non-examples? Because they have an equal sign. These are equations. We're back to what? Expressions only. That's why you write expressions only, various terms. Copy that, please. Copy these steps, please. 4 small steps. Number 1, identify the GCF for every term. Number 2, rewrite the polynomial using the GCF and the remaining expression. And number 3, check your answer. Copy those, please. It says, identify the greatest common factor for every term, rewrite the polynomial using the GCF and the remaining expression as factors, and check your answer. So, just to clarify some definitions before we move on. Yesterday I gave you guys definition for factors, and I said 2 or more numbers that multiply, because we were only dealing with basically numbers, right? But since now we're in polynomials, factors are numerical and variable expressions that multiply. Does that make sense? So, factors are numerical and variable expressions that multiply. Alright? Factoring. What is factoring? The process of finding the factors. So, let me ask you this. If I was to give you the number 1,245, Isaac, what are the factors of 1,245? 2. It doesn't end in an even number. 5. What is the other factor? Wait. What are you doing to find the other factor? He said dividing. Is that correct? So you would divide in here, so it would be 2, 4, 9. Therefore, my factors are 5 and 249. But what was the process that I did to find those 2 factors? Division. And what is the definition of factoring? The process of finding factors. Therefore, factoring is what? Dividing. So from now on, whenever you hear factoring, what are they implying? Dividing. Are we there? At the beginning of the year, we multiplied. That's why we were finding areas. We were finding, we did the area model, remember that? And all that fun stuff. So, today we're going to be focused on division. So, copy this down, please. Example 1A. It says, factor each polynomial and check your answer. Factor each polynomial and check your answer. 2x squared, bless you, minus 4. 2x squared minus 4. Here we go. Pens down, eyes up here. So, according to what we did last night, we did something similar to this. Let me zoom in so you guys can see it. I left you guys 4 sets to find me the GCF and LCM. Is that correct? So if I was to ask you to find me the GCF for these two, and you're saying, but it doesn't look the same. Well, let me show you. How about now? Does that look like kind of like what I left you last night? Yeah, right? So therefore, if I was to factor this one completely, this is already a prime number, so I just leave it as 2. Is that correct? This one becomes what? X times X. This one becomes 2 times 2, but it has a negative, therefore times -1. Are we there so far? You're just paying attention, please. Therefore, what is common here and here? 2. That would be our GCF, right? It would go in the middle. 2. Do we have an X on this side? No. So, what's left over on this side? X squared. What's left over on this side? -1 and positive 2. So check this out. This is how we write the remainder. X squared minus 2. Copy that. Yes, Bam is right, and that's why I left you that home plate so you guys can be ready for today. And I just made a rhyme right there. Did you guys notice that?
No.
No?
Okay.
Yeah, I know. Then I would say, hey. No, never mind. So these are known as factors. Factors. Why are they factors? Because they're multiplying. Let's see. Is this a number? Yes. Is this a variable expression? Yes. Are they multiplying? Yes. That's why they're known as factors. Everybody got it? But then it says the instructions say to check. Check. So I'm going to rewrite this. 2x squared minus 2. So what was the process to find the factors? Division, right? To check it, we're doing the opposite, which is what? Multiplication. So therefore, what is 2 times x squared? 2x squared. What is 2 times -2? -4. Is that what we started with? Yes. So now, that was the long way. Let me show you the shortcut. Everybody ready? There is a shortcut. Here it goes. Pens down, eyes up here. And this is where I want us to focus on the shortcut from this point forward. This right here is factored. That's why at the beginning of the year I said, if when in doubt, factor out. That's what you do here. But here goes the shortcut. Here we go. Question. What number divides this term that divides this term? 2. And that's the biggest number that we can find, right? So, 2. Is there an x on this term over here? No. That means our GCF is 2. And to find the factors, what did we say factoring was? Dividing. So therefore, we divide each term by 2. So this is a giant 1. What's left? X squared. What is -4 divided by 2? Copy that, please. Why didn't I tell you that? Because I wanted you to first see what I showed you how to do last night. And then if that fails, then just go with a shortcut. There it is. Copy that, please. Be nice. All right, let's move on to the next one. That was 1A. Copy this next one. Example 1B. You don't have to copy the verbatim anymore. Just copy the expression. -14x minus 12x squared. So, let's see if we can use the shortcut on this one. Let's do this one together. What is the biggest number that can divide both terms?
2.
2, okay. But notice that both terms have a negative, don't they? So therefore, we're going to say it's -2. So far, so good? All right. Do both terms have 1x? Yes. Do both terms have an x squared? No, so we stop right there. So that's our GCF. So we're going to find the other factor. And what did we say the process was? Division. So -2x divided by -2x. Therefore, what is -14 divided by -2? 7, and the x's became a giant 1, so it's already there. Are we there? Okay. What is negative 12 divided by negative 2? Positive 6. And what is x squared divided by x? X to the first. And these are our factors. And to check, what do? We write negative 2x, we're going to check. Negative 2x times 7 plus 6x. Let's distribute. Negative 2x times 7, that's negative 14x. Negative 2x times 6x, so negative 2 times 6, that's negative 12. Negative 12, x times x, x squared. Did we end up with what we started? Yes. Once again, if you don't see it, when in doubt, factor out. So this one, the 14 becomes negative 1 times 2 times 7 times x. Do you guys see it? The negative 12 becomes negative 1 times 2 times 2 times 3 times x times x. And then you go one at a time. Let's see. What do both of them have in common? Do they have a negative? Yes. Do they have a 2 in common? Yes. Do we have an x in common? Yes. What's left over here by itself? The 7. What's left over here? The 2 and the 3 and the 1x. How are we doing? Let's do another one. Copy this one down, please. Example 1c. Eight x cubed, negative 4x squared, negative 16x. Okay, let me make some space. Whoop, sorry. How many terms do we have now? 3 terms, alright? But still, the question is the same. Instead of going this way, because on mine it doesn't fit, I'm going to go down here. So, what is the greatest number that we can divide into each term? 2 is the greatest number? 4 is the greatest number. Okay? Does each term have an x? Yes. Does each term have at least an x squared? No, this one only has an x, so that's why our GCF is 4x. So let's see what's remaining. Divide by 4x, divide by 4x, divide by 4x. Let's see. What's left here? 2x squared. This is negative 1x. And this is negative 4. How are we doing?
Why is x squared? Why is it on top of x? Oh, because you use the x.
Because part of the GCF is this. Now, since we're dividing, who remembers the rules for division? If they have the same base, what happens to the exponents? Subtract. Yes. Yes.
What about...
Alright, so for the sake of time, we're not gonna be checking from this point forward. I just want us to factor. Are we there? Alright, copy this next one, please. This has a little curveball. See if you catch it. Example 1D. 3x cubed plus 2x squared minus 10. Go. You have 15 seconds. Alright. The greatest factor for each term was 1. Since the last term did not have a variable, we cannot add a variable there. Therefore, 3x cubed plus 2x squared minus 10. And we're done. You're saying, Mr. U, it basically stays the same. Well, yeah, but now we have a factor of 1. Why do we need that? Because when we get to the next part, you need to remember that. Whenever there's nothing that you can factor out, there's always a what? 1. Are we there? Let's move on. Copy this next one. Example 1E. Do this one by yourself. 8x to the 4th plus 4x cubed. minus 2x squared. Go. Okay, let's see. What you get for the GCF? Haley. Two what? No, the GCF. I just want the GCF right now, which is a leading factor. 2x squared. Hands if you got that as GCF. That is correct. And what's the remaining factor? Let's see. 8 divided by 2, that's 4. X to the 4th divided by x squared is x squared. 4 divided by 2, that's 2. X cubed divided by x squared is x. And negative 2x squared divided by 2x squared is negative 1. Hands if you got that. That is correct. Now, let me show you what I see to see if you already saw it. Some of you might have already seen it, some of you not. But let me show you to see if it can be obvious from this point forward. Look up, please. All right. Look up, please. What was the GCF for this one? Negative 2x, right? What was the variable on the GCF? X to the first, right? What was the smallest variable of the original one? X to the first, okay. Okay. Look at this one. What was our GCF for this one? 4x. And what was the smallest, what was the variable that we used? X to the first. What is the smallest variable of this whole thing? X to the first, okay. We just did this one. What was our GCF? 2x squared. What was the variable that we used for the GCF? X squared. What is the smallest variable of this whole thing? X to the second. Therefore, what can we conclude? The GCF has to have the lowest variable. Did everybody catch that? Yes? Okay. Here, let me illustrate for those of you that are still like looking at me weird. 32x to the 7th plus 40x to the 10th plus 8x to the 5th. What would be our GCF? First of all, what number divides into each number? The biggest number is 8. Okay? And what is the smallest variable? X to the 5th, that would be our GCF. Everybody got it? And then from there you just do your division. This becomes 4x squared, this becomes 5x to the 5th, and this becomes 1. So far so good? Yes? No, that was last night for factoring GCF and LCM. For today, we're going with the greatest common factor, which is any greatest factor that they have in common. Okay? You alright? Alright, copy this next one. Do this next one by yourself. Negative 18y cubed and negative 7y squared. Okay, who's got the GCF? Oliver.
One y squared.
Negative 1y squared. Hands if you got that as your GCF. Why negative? Because both of them are negative. That is correct. And we're left with 18y plus 7. Hands if you got that. Okay. Let's go to the next one. Don't copy this one. Let me just illustrate because I need to get to a couple more. When they talk about areas in word problems, Here they say the area of a court for squash is 9x squared plus 6x meters squared. Let's see. Here's the area of a court, and they give us 9x squared plus 6x, and they ask us for the dimensions. What is GCF for this one? Oh, 6x. What is it? 3x, so therefore we're left with, this is 9 divided by 3 is 3. We're left with x plus 2. So the dimensions are 3x times 3x plus 2. So basically we're just factoring. Yes? Alright. Copy these. Example 3a, and I'm going to go over this one. Look up, please. So now, here we have binomials. Look up, please. Look at A. We have a binomial. Why do we know that? Because here there's multiplication, but here there's an addition. So there's one term, two terms. So that means we have two factors here, don't we? This times that, and this times that. If we have factors, then what factors do these two have in common? What is our greatest common factor? Who sees that it's x plus 2? X plus 2 is our greatest common factor. What's left on this side? 5, and then you put the plus. What's left on this side? 3x. Those are my factors. Copy that. See if we can do B together. What is common for this term and this term? B squared plus 1, okay, which is this one and this one. What's left over for this term? Negative 2b plus, what's left over here? What? 1. Those are my factors. How are we doing? Okay, let's do a couple more. Copy these. Don't do C, I want you to do D. Example 3D. Get it, 3D? No. Copy that one, see what you do, see what you get. Okay, so what's in common for this term and this term? 2x plus 3. What's left over for this term? 7x plus 1. Hands if you got that. Okay? Alright. Let's move on for some funner stuff. Copy this one. Example 4. Copy that, please. Six h to the 4th minus 4h cubed plus 12h minus 8. So, notice this one is a little bit different, doesn't it? Okay, whenever you get to the 4-term expression, we can use a method called by grouping, factor by grouping. Watch, I'm going to group these first two and these second two. So watch. I'm going to start with these two first. What is our GCF for these two? 2. What is the smallest variable? H to the 3rd. So therefore, that leaves me with 6 divided by 2, that's 3, and 1h. Negative 4h cubed divided by 2, that's negative 2. Are we there so far? Bring down the plus. What is the GCF for this one? 4, and what's left? 12h divided by 4 is 3h. Negative 8 divided by 4, that's negative 2. Does this look familiar? What's common for each one? 3h minus 2, which is this and this, and what's left over? 2h cubed plus 4. and these are our factors. So, home plate for tonight is found on pages 529 to 531, numbers 1 through 28 only. Have a good one, guys. It's tutoring today. If I don't see you here, see you guys tomorrow. You're welcome.